In the real world, the amount of products that we predict that we will get is almost never the amount we actually get. The reason is because at times there will be some side reactions that will ensure that we never get how much we believe we should get. Let me give you an idea of what I am talking about. Take a look at my recipe for making pancakes. If I have a lot of flour in my house, I have this in excess. And I have a lot of eggs in my house. I also have that in excess. But I only have 15 ounces of milk. How many pancakes can I actually make? Well, using the relationship between what we know and what we want, 3 ounces of milk will normally give us 5 pancakes. We can easily calculate how much pancakes we expect. If you put this into your calculator, you should get 25 pancakes. So, if I have 15 ounces of milk, I expect 25 pancakes. That is very straightforward. But let us assume that while I am making the pancake, I burned 2 of them. I did not plan to burn 2 pancakes, but I actually ended up making only 23 pancakes. So 2 pancakes got burned, which means I ended up with 23 pancakes. What I actually got, the amount of pancake that I actually got is the actual yield. But this is the amount of pancakes that I expected to get based on how much ingredients I have. This is the expected yield. The expected yield at times is called theoretical yield. That is, in theory, that is how much pancake I should get. The relationship between the amount of pancakes that I actually get and the amount of pancakes that I expected to get is what is known as percent yield. And this is the equation of the relationship. The actual yield divided by the expected yield, or the theoretical yield, if you will, times 100 is the percent yield. Remember this equation. Let us now take a look at a chemical example to drive home the point. In this example, we have 200 grams of PCl3 reacted with excess water. 200.0 grams of PCl3 is reacted with excess water. And the reaction leads to the collection of 113 grams of HCl. 113 grams. The question is to calculate the percent yield. Immediately I see this question, I'm thinking of how do I find the percent yield? We know the expression for finding percent yield. We need to find the actual yield. We also need to find the expected yield. And the ratio of the two should be multiplied by 100. So how do I find the actual yield and the expected yield? The very first thing you should notice about this question is that the equation given to us is not balanced. Now, if the equation of the reaction is not balanced, that means the recipe is wrong. We need to balance it first. If you do not, everything you do would be wrong. So to balance this equation, if you place a 3 right here, because we now have 3 chlorine on both sides, and you place a 3 right here as the coefficient of H2O that has 6 hydrogen on both sides of the equation is now balanced. Now, let us now examine one other thing from this question. This is an important thing to observe. The mass of one of the products in the reaction is given to us. Now, there is no way anybody would know how much of a product is actually made unless the reaction has been performed. If you remember my pancake example, I only expected 25 pancakes, but I was only able to make 23. If you had told me at the beginning that I would make 23 pancakes, I would not believe you. The fact that we know the mass of the product in this question means that this experiment has been performed, and this is the actual yield. That was exactly what they got when the reaction was performed. Now let us find the expected yield. It is the same calculation we have done several times. We will need to convert the mass of PCl3 that was provided as the mass of the reactant. We will need to convert it to the moles. And if you look at the periodic table, 137.32 grams of PCl3 is equal to 1 mole of PCl3. That is the molar mass. Grams of PCl3 will cancel out. Then we can relate what we know to what we want. We want to know how much of the HCl we expect to make based on 200.0 grams of the reactant. And the relationship is that 3 moles of HCl would be made from 1 mole of PCl3. Moles of PCl3 will cancel out. Then we can change the moles of the HCl into the mass. If you look at the periodic table, 1 mole of HCl has a mass of 36.46 grams. Moles of HCl will cancel out. So whatever we get now will be the grams of the HCl. And if you use your calculator, that should give you 159.306,728 grams of HCl. What we just calculated is the expected yield. That is how much we thought we should get based on how much ingredients we have. Let us now find the percent yield, because we know both the actual yield and the expected yield. So the percent yield will be the actual yield, 113 grams, divided by the expected yield, 159.306,7288 grams, times 100. And that should give you approximately 70.9% based on the measurements provided to us. Let us now take a look at one more example. Determine the percent yield of a reaction in which 41.5 grams of tungsten 6 oxide. The formula for tungsten 6 oxide is WO3. W is the symbol for tungsten, and the name says that we have a charge of +6 on tungsten, and oxygen is always with a charge of -2 because it is from group 6A. So tungsten 6 oxide will be WO3, and we have 41.5 grams of it. When it reacts with excess molecular hydrogen is in excess. To produce atomic tungsten, in the elemental form, and 9.50 grams of water. That is the question. Remember, we want to find the percent yield, which means we need to find the actual yield and the theoretical yield. But as you probably already noticed, the equation of the reaction was not given. We have to write it out and balance it. The balanced equation for this reaction will have a coefficient of 3 for the hydrogen and a coefficient of 3 for the H2O. Now, let us look at one other thing. The mass of one of the products is given. And again, you know that you cannot know the mass of a product that you will exactly get unless the experiment has been performed. So, since the mass of the product was provided, that is the actual yield. That was what was actually obtained when the experiment was performed. So all we need to complete this reaction is the expected yield for water. And we can simply begin from 41.5 grams of WO3 and convert that to moles. Using the periodic table, find the molar mass of tungsten 6 oxide. You should get 231.84 grams as the mass of 1 mole of tungsten 6 oxide. Grams of WO3 will cancel out. Then we can relate what we know to what we want. The relationship is that 3 moles of H2O will be obtained from 1 mole of WO3. As written, moles of WO3 will cancel out. And then we can convert the moles of H2O to its mass. From the periodic table, 1 mole of H2O will have a mass of 18.02 grams. Moles of H2O will cancel out. If you put all of these numbers into the calculator, you should end up with 9.67688.923 grams for water. Now, we know that percent yield should be equal to the actual yield divided by the theoretical yield or the expected yield multiplied by 100. In this calculation, the expected yield is 9.67688.923. So the percent yield will be equal to 9.50 grams, which is the actual yield, divided by 9.67688.923 grams, which is the expected yield, times 100. And if you put the numbers in the calculator, you should get approximately 98.2%.